I then took what I learned at Ball State back to my classroom at Elkhart Central High School. I was at Elkhart Central for 7 years and then was invited to go back to my alma mater, Penn High School. And I really had to take a look at what my students needed to learn in physics and redesign the way that it was taught, because I knew that the traditional method was not working for them. They were bored, they were not engaged at all, and I needed to change things up. So these were a few things that I kept in mind and I really geared myself towards. The first thing is to follow a constructivist learning theory. I want my students to be scientists, and I want them to learn science, and specifically physics, the way that our humans in the past learned physics. If that's the way they learned it, why can't my students learn it that way? So we follow a constructivist learning theory. Labs always come first. My students have no idea what they're doing, and that's fantastic. Because if they have no idea what they're doing, they're not afraid to try things and just see what happens. And then we can bring that data together as a class and decide, how does this stuff really work? And that's how we learn physics, by doing the labs first, not by me dumping a bunch of information in their brain, having them do a lab and get the result that they know they're going to come up with anyway, which was always one of my greatest frustrations. The next thing is that the labs contain the content. The labs are what drive my course. It's not anything to do with the textbook. And in fact, I frustrated my entire administrative team this year as we were going through science textbook adoption in Indiana, and they kept asking me, what book do you want? What book do you want? And I kept saying, I don't care. I don't care what book you give me, because my labs contain the content. It makes absolutely no difference to me if you even give me a book, because let's be honest, my kids aren't going to open it, right? My students are not going to open that textbook unless I make a specific directed reading where they have to get into that textbook. They just aren't going to books to gain their information anymore. So it frustrated them to no end that I wouldn't pick a specific book, but that's not really the way that my students learn. They learn through doing, and they learn through doing and manipulating the labs that I've designed for them. When I started teaching physics at Elkhart Central High School, we had absolutely no money in our budget. Very little money for the science department to share between 15 or 16 teachers. Extremely antiquated equipment. In fact, when they took me to the physics lab, the air tracks were connected to Apple IIgs computers. And I thought, no. No, you can't put my students on these computers. They're older than they are. They have no idea what these do. You know, it runs by a floppy drive, people. This is not going to work for them. And so what I did was I redesigned every lab experiment and activity that I came up with to use very cheap, inexpensive equipment that you can buy at like a Walgreens or a CVS or a Walmart, so that your students can do those labs, get the correct information that they need, even without your school having the very expensive equipment, because not all schools have that, unfortunately. We start the very first day of school with a lab. If I want them up out of their seats and doing labs the entire year, then I need to start that way on day one. So when my students walk in the very first day, we are playing the song from the Olympics, and they are told that they will be competing. I know they've been practicing all summer in some events like the cotton ball shot put, the straw javelin throw, the paper plate discus, and they're taking measurements, and then eventually they are converting all those measurements into every metric unit possible, which they hate that part, but they love the first part. And they get to compete for gold medals, and it's always a favorite. The students remember this lab. They come back every year and ask who won the medals. I take pictures of the gold medal winners, laminate those pictures, and they're out in the hallway for the entire year so we all can bow down to the metric Olympic winners. Well, just like I thought I would never be a high school physics teacher, I certainly never thought I would be an author either. And after presenting a lot of my lab activities at our state science teachers convention called HASTE, the Hoosier Association of Science Teachers Incorporated, many of my friends encouraged me to put it all together, because people were always asking me for copies of things and emailing me, can I have this lab? Can you give me a copy of that? And so I eventually finally sat down and put everything together and came up with Teacher-Friendly Physics, which was published in 2009. Contains 30 guided inquiry labs. They're the exact same ones that I do in my classroom. This first volume covers motion, energy, and forces. I'm working on volume 2, but somehow when I became Indiana State Teacher of the Year, I had no idea how hectic my life would become, and so it's kind of right now on hold and perpetually on hold until we name the next Teacher of the Year. But doing this has been one of the greatest joys for me. It's certainly something that I never thought that I would do. And if you take a look at that picture, isn't that fantastic? Right, the tree and the apples. That was designed by the other little girl that you saw in the very first picture. There was my younger sister Courtney, who was sitting next to me. My sister Courtney hates math and science. detests math and science, but she's amazing when it comes to graphic design. And I said to her, I really need a cover for my book, and I kind of, I'm trying to describe it to her. She has no idea what I'm talking about, but this is what she came up with, and it's absolutely exactly what I would have wanted had I known what I wanted. So I owe her a big thank you for that. Usually people want to hear about, what you've learned, what your research is. And my research is watching teenagers all the time and trying to figure out what works to make them learn physics. So these are some things that, as I have gone through teaching for the past 12 years, some things that I have learned that have helped me in my classroom and hopefully will help you too. First one, labs cannot be more than 1 page long. You can take a 4-page lab and shrink it down to 1 page and you'll be fine. But the moment that it's more than 1 piece of paper and there is a staple involved, you can expect whining. Right? So all of my labs are like so small, so tiny, but if it's on 1 page, if you give them 1 page, that seems like something that I can do in a class period. I can handle that. But the minute that it's anything longer than that, they're gone. They're absolutely gone. Next one, use technology as much as possible. Some examples, I use a lot of formative assessments in my classroom. We do formative assessments almost every day as we're learning new material, and especially before a summative assessment. And I call my formative assessments DUGIs, D-U-G-I, and that stands for Do You Get It? And so we do DUGIs before every summative assessment to help my students understand and key in on what am I not understanding and where do I really need to focus my study before I walk into a test. The other thing that I do a few years ago, I started doing online homework. I used the CALM system, computer-assisted learning method through Indiana University. It was originally designed for chemistry use, but now has been opened up. Anybody can use it for free. You just simply have to program the problems in. And what I love about the online homework is whereas before my students, if they didn't get a problem, they would simply find someone who got the problem and copy. Now, each problem is specific to them. So they cannot try to do someone else's problem. And if they do, it will say, good job, but this is not your problem. Click here to go to your problem, which frustrates them. But when I'm able to show them how their scores have gone up since before we started using the CALM online homework system and to now, they understand why I make them do that. So every time they get a homework assignment, it's maybe 10 to 20 problems. They have 2 weeks to do those 10 to 20 problems. So lots of time to get help if you don't understand what's going on. Multiple activities per class period. 15 seconds is what I heard Brian say about kindergarten students. It's about the same for high school. You really need to have multiple things that they are working on. You cannot simply give them one activity and expect them to stay engaged. We have 88-minute class periods. That's not going to work. You have to have multiple things that they're working on. So we always have research projects going on as well that they can be working on. For instance, this spring, my students were looking at President Obama's energy policy and writing letters to him evaluating his energy policy for the United States. So they always have exterior projects that they can be working on if they have any downtime between labs. Next one. My students do not care about anything that I have to say until they know that I care about them. And I take a lot of time at the beginning of the year making it known that we are a family. We're going to fail together. We're going to fail big. But we're going to learn from those failures. And my students have said that we feel like a family. We make fun of each other. We joke around a lot. And I think that's part of what makes them enjoy physics. We have a school of 3,600 students. We have 3 full-time physics teachers in that building, which is just incredible. Next one. I'm convinced that if I just simply give my students the answers, I've not taught them anything. But if I can teach them to find the answers on their own, then I've done my job. The next one, I read this in an article, and this is terrible, I can't remember where I read it. I read a lot of things, and I remember about 5%, honestly. And there was an article that I was reading about learning styles, and it was talking about how in the last generation, when people wanted to gather their information, they sat around for the 6 o'clock news, right? They all gathered together, they all sat, and they watched the news. This generation does not get their information that way. They are a participatory generation. So rather than broadcasting information to them and expecting them to understand it, we need to use their participatory culture and teach to them that way. So what will my students remember after they leave my classroom? Formulas? Probably not. Really? And honestly, I'm okay with that. I always tell my students, whenever the year starts, they always ask, do I have to memorize these formulas? No. Why would you memorize something that you can Google and get an answer to in less than a second? There's absolutely no point. So there's no memorizing. It's all about using those upper level thinking skills and analyzing a problem. Will they remember the labs? They do. They do remember those lab experiences. They remember the metric Olympics. They come back during the year and they say, what lab are you doing today? Oh, I remember that one. And amazingly, they'll remember their results. It's absolutely fantastic. So getting them engaged is exactly the way to go. Will they remember me? Probably, because I'm a big goofball. So chances are they will remember me. They won't remember all those nitty-gritty details about physics, but that's part of the learning process. What I hope they learn when they leave my classroom: show up and work hard. I have a lesson that I give my students towards the beginning of the year. I know that when they're absent that it affects their grade, and I would say that over and over again. They didn't believe me, so I graphed it. And I showed them that for every day that you are absent, on average, your grade goes down by 1.3%. And that's a shocker to them when they see that. You've got to show up. Just showing up helps you out in ways that you'll never understand. And when you're there, you might as well put in the effort. No procrastination. It's a big problem with teenagers, and they're still learning this one day by day. Just because somebody tells you that something is difficult doesn't mean that you can't learn it. You can, just like this blonde girl did. Thank you guys so much.
I'll have to ask you to come down after we're adjourned if you have questions for Stacy.